France is baking under extreme heat.
Germany is struggling with devastating floods.
England is experiencing unusual weather.
China is being hit by relentless torrential rain. 4 countries. 4 completely different weather disasters. Thousands of kilometers apart. So here's the question. Could they all somehow be connected? Surprisingly, the answer is yes.
Not because one event directly caused another, but because they may all have been influenced by the same global climate system. That climate phenomenon is called El Nino.
To uncover how this is possible, let's explore 11 fascinating questions about El Nino. Q1. Is El Nino causing all these disasters? Not exactly. This is one of the biggest misconceptions.
El Nino doesn't create every storm, every flood, or every heat wave. Each event has its own local weather systems. Instead, El Nino changes the background conditions of Earth's atmosphere. Think of it like loading a pair of dice. You don't decide which number appears, but you increase the chances of certain outcomes. So, what exactly is El Nino? Q2. What exactly is El Nino? El Nino isn't a storm. It isn't a hurricane. And it isn't climate change. It's a naturally occurring climate phenomenon. Every 2 to 7 years, the surface waters across the central and eastern tropical Pacific Ocean become significantly warmer than normal. Not over a small area, but across millions of square kilometers of ocean. But why does such an enormous area of ocean suddenly become warmer? Q3. Why does El Nino happen? Under normal conditions, steady trade winds blow across the Pacific from east to west. They push warm surface water toward Indonesia and Australia. At the same time, cold, nutrient-rich waters from the deep ocean along the west coast of South America. Scientists call this together, these processes keep the Pacific Ocean in balance.
But every few years, those trade winds weaken. Without those powerful winds, the warm water slowly spreads back toward the central and eastern Pacific. As a result, the cold upwelling weakens, and a vast region of the Pacific Ocean stores much more heat near its surface. But how can warmer water in one ocean affect countries on the other side of the world?
Q4. How can one ocean influence the entire world? Imagine placing a giant heater in one corner of a room. The warm air doesn't stay above the heater. It spreads throughout the room.
Earth's atmosphere behaves in much the same way. The unusually warm Pacific releases enormous amounts of heat and moisture into the atmosphere. That extra energy changes atmospheric circulation. Clouds begin forming in different places. Rainfall patterns shift. Jet streams move. Storm tracks change. Now, let's return to those 4 countries.
Q5. Why did France experience extreme heat? Europe sometimes develops persistent high-pressure systems during summer. These systems trap hot air near the ground.
If El Nino has already raised global average temperatures, El Nino doesn't create its heat wave, but it can increase its intensity. Then why wasn't Germany simply hotter too? Q6. Why did Germany experience floods instead? Because Germany's weather is controlled by different atmospheric conditions. Floods occur when slow-moving weather systems release enormous amounts of rain. El Nino can influence the large spheric circulation, but local European weather patterns ultimately determine where and when the rain falls. Then what about England? Q7. Why was England different again? Britain's weather is strongly influenced by the North Atlantic Ocean and the jet stream. El Nino can slightly shift large-scale circulation patterns. Some seasons become warmer, some become wetter, others become drier. That's where El Nino's influence becomes much stronger.
Q8. Why did China experience torrential rain? The warmer Pacific releases more heat and moisture that alters where monsoon rains develop. Some parts of China receive exceptionally heavy rainfall. Other parts of Asia may experience drought. People confuse El Nino with something else. Q9. Is El Nino the same as climate change? No. El Nino is a natural climate cycle. Climate change is the long-term warming caused mainly by human activities. However, when a strong El Nino occurs in an already warmer world, the two can reinforce each other, making heat waves, heavy rainfall, and droughts Q10. Can scientists predict El Nino? Yes. Thousands of floating ocean buoys, weather satellites, research ships, and computer models monitor the Pacific Ocean. Scientists can often detect the development of El Nino months before its strongest impacts are felt. So, what's the biggest lesson? Q11. What should we remember about El Nino? The weather disasters we saw at the beginning weren't identical, but they all influenced by one enormous climate engine operating thousands of kilometers away, one unusually warm ocean, one atmosphere. And that's why understanding one ocean can help us understand the weather of an entire planet. So, when you hear about heat in one country, floods in another, or relentless rain far away, remember, our planet's weather is far more connected than it appears. One unusually warm ocean can influence the atmosphere across continents, changing the likelihood of extreme weather in places far away. That's the extraordinary science behind El Nino. And that's exactly what Science Unlocked is all about. Uncovering the hidden science behind the world's most fascinating mysteries. Until next time, keep asking questions, keep exploring, and keep unlocking the science behind our world.